Okay, on number 5, we're going to be looking at more applications of derivatives. So let's go back to talk about what a derivative is. When we say f prime of x, what do we really have? Good. We really have the slope of the tangent line, right? Well, what is slope? Good. Slope is change in y over change in x. That means we can write change in y in terms of derivative. Or we could write change in x in terms of derivative, right? If we wanted to solve for change in y, we would multiply by change in x. And we would get that change in y is equal to f prime of x times change in x. Now, remember that we also kind of say that f prime of x is dy over dx. Remember that terminology? So another way to say change in y is dy. And another way to say change in x is dx. So instead of change in y, I can say dy. And in place of change in x, I could say dx. And then we're kind of talking about differential y, differential x, which really, in our mind, going back to algebra 1, is changing y in relationship to change in x. Well, that's kind of cool because remember our delta epsilon thing where we were saying if there's this much error in x, then how much error could we have in y? Or if we have this much allowable error in y, then how much allowable error will we have in x? Well, this is an easy way to find that. And in machine shops and things, that's important. If we're going to say we're going to create something that has this limitation in the input, what type of discrepancy does that then allow in the output? Okay? So, if we wanted to find differential y in this particular equation, then we would first want to find the derivative of y in terms of x. We'd find the derivative. We'd say that y prime is equal to what? 6x. And so my differential y then is equal to what? Differential y is equal to 6x times dx. So differential y is 6x dx. I'm going to rewrite that. Differential y is equal to 6x dx. So I found differential y of a given function. Okay. So all we did is found the derivative, and we realized that dy is derivative times dx, which all came from our slope formula, as we just derived. Okay? So that gives us an equation to use to find what? If we have this much input error or change in x, then how much output error or change in y might that produce? You see? Given that we're allowing so much input error, how much output error is that going to kind of like our delta and epsilon situation in a more streamlined method. Okay, so we're going to make application of that on number 6. It says the measure of a side of the square is found to be 12 inches. With a possible error of 1/64 inches. Use differentials to approximate the possible propagated error in computing the area of the square. Now, let's talk about that. First of all, we need to think about side area relationship, right? What is side area relationship in a square? Area equals side squared. So what I'm wanting is differential area in relationship to differential side, correct? Now, what is an equation that would give me differential area in relationship to differential side? Differential area is equal to F prime of side D side. Remember that dy is equal to F prime of x dx. There's my formula. Differential y is derivative of x dx. My y is area. My x is side. So differential area is equal to F prime of s dx. See how that fits right into that? So we need to find A prime, right? A prime is going to be what? 2s. What is ds? ds is the error in the side, correct? How much allowable error was there in the side? 1/64 of an inch. Now it could be too much or it could be not enough. So plus or minus 1/64 is the amount of error in the calculation of the side. There's my differential side or my change inside, the amount of error that I had there, my delta x. And so I'm looking for dA. How much error would that create in the area? So differential A, change in A. Okay? Understand that? Okay? So in this formula, then what I have is dA, which we don't know, is equal to F prime of my side, which is 2s, times ds, which is plus or minus 1/64. Okay. Well, do we know S? 12 inches. So we're going to have dA is equal to 2 times 12 times plus or minus 1/64. So we have dA is equal to plus or minus 24/64, which is plus or minus 8 goes 3 and 8. So the propagated area is plus or minus 3/8, and we're talking about area, and that would be in square inches, right? So if we measured the side of 12 inches with a possible area of plus or minus 1/64, it would give us a propagated area in the area of plus or minus 3/8. Okay. Understand how we do that?